Welcome to the session. The topic, BGP is not only a TCP session. This is the last session for today before the party starts, or the packet challenge, or whatever you called it, yeah? I choose this topic because of BGP. It's for me a TCP session, yeah? When I'm here at SharkFest several years ago, everyone was talking about TCP, yeah? And I gave some talks last year, although this year in Asia, about layer 2 stuff. And I was surprised how layer 2 are involved in a routing protocol like BGP in today's data center networks, yeah? And that was for me crazy. They routed MAC addresses over a layer, yeah, whatever you called it, 4 to 7 routing protocol on a layer 2 stuff, yeah? And I was thinking, okay, I will talk to you guys on SharkFest how I learned BGP in another way, yeah? Because I was learning BGP, how you configure it on a router, on a data center or whatever, call it, or service provider environment. But finding out, configuring is one thing, but understanding what's happened on the wire is another thing, yeah? And I will show you in this session what's going on, and my way, because Hansang told you in the morning or in this 2 session, yeah, his way is the highway, yeah? And I would say maybe this is also a highway to hell, maybe? We will see. Okay, let's start, yeah? First of all, I collected some RFCs and capture files. I found it everywhere, yeah? Because I'm not capturing BGP in a live network, because it's not needed for me, because so many PCAPs are available around on the internet, yeah? And I put everything together, and I put it all in a zip file with RFCs and other things, and then we will start with that, yeah? Okay, so let's go. Is it working or not? This is the agenda for the next 90 minutes. Hopefully I will go through, because a lot of slides and discussion, hopefully, yeah, maybe afterwards, yeah. So I thought this picture, who knows this? Who have seen that picture before, yeah, with the Lego bricks that called, yeah? Okay, you can see it? Okay, who knows it? It's IPv4 header, yeah? So bit offset and so on, blah, blah, blah. This is layer 3, yeah? And BGP was originally assigned to pronounce some prefixes, yeah? To route prefixes. BGP is a control protocol for data protocols, and IPv4 is one of these data protocols, yeah? Right now we have more than IPv4, yeah? We have IPv6, we have layer 2 MAC addresses, or what else, yeah? And with BGP, I give you some hints how you can make further research, and I look into some BGP messages, yeah, what's going on. Have a look on that. BGP telling you when something's going wrong, yeah? Authentication and security also a little bit, yeah? And then in BGP, they changed the autonomous system numbers from 2 byte to 4 byte, yeah? And when they work one system with 4 bytes, the other system with 2 bytes, and say how can interact and what's happened also then, yeah? Communities and BGP link signaling, yeah? So they interact with OSPF or ISIS into BGP right now, yeah? In former times I learned, yeah, how to redistribute from one system to another system, yeah, or from one routing protocol to another routing protocol, yeah. This one here is a very good topic, BGP EVPN, Ethernet Virtual Private Network. It's what's up to date right now in a data center, yeah, for single home, multi-home, and so on, yeah. And also, I have a look very short with the Graceful restart feature. But let's go on. A little bit about me. You can read that afterwards. I think it's not so needed, yeah. This is more important, yeah. The history of BGP. BGP was a protocol that was designed on a, I think was IETF meeting, on a napkin, yeah? And here in this building, yeah, they have this scan of the napkins, yeah? And it's hard to read in the background, sorry again, but you can see different kind of messages they defined on the napkin, yeah? And these messages right now, today, also valid, yeah? So, BGP Border Gateway Protocol, yeah? Different version. The actual version right now is version 4 with some extension. And what I found out in my career, a protocol, yeah, who is designed with a type length value. So it's extendable. This protocol will survive, yeah. IPX was not type length value, yeah. No IPX anymore from Novell, yeah. But you see it always when you capture on customer networks sometimes, yeah, by misconfiguration. I was in a session today about security and crypto and blockchain and whatever, and I was thinking, BGP and security, yeah, what's happened with that, yeah? The 3 or 4 points here, BGP, security, and crypto. What's happened? Some guys always hijack BGP, yeah? And they redirect the DNS services from Amazon, I think, to get money with Bitcoins, yeah? That was happened, yeah? BGP hijacking, Amazon DNS to steal cryptocurrency, yeah? And then I got one of these drawings, yeah, and I found it, oh, but we are not talking about this right now. We are talking about BGP, yeah? What is BGP and different version of BGP? And right now, with Wireshark, I was jumping too late with BGP into the area because I was hoping having a capture with BGP version 3 or version 2 or 1, yeah? In the former days, yeah? Anyone of you guys have captured a BGP transaction with version 3 or version 2? I see some experienced guys here in the audience. No one? Okay, like me also no, yeah? And this was in the former times. I have another protocol analyzer. You must switch between the version, yeah? And I was reading in these RFCs, I put it also on the share. What are the difference between the versions, yeah? Anybody know? What is one difference between BGP version 3 and 4? Nobody? Version 4 is you have subnetting, yeah, so /23, yeah. In version 3, you have always class full. With version 4, we have right now classless routing, yeah, or CIDR, yeah, that's also called. A lot of RFC. These are the basics RFCs, yeah. And like me, I'm traveling a little bit, yeah. And when I'm sitting on the airport or back from SharkFest, yeah, sitting at the airport, okay, which PDF I can read, yeah. And then you, yeah, it's very funny sometimes to read RFCs. And I put it all on slides here. A lot of RFCs, I put it also on the supplemental, yeah. So when you go back from SharkFest, you have a lot of RFCs in your file share, yeah. You can read it. And a lot of capture and see what's going on, yeah. So this means, for your information, I will jump over because time is flying very fast. Another thing is, what I use very often is bugs.wireshark.org. Who of you guys have used the bug database to extend your protocol knowledge? Please raise your hand. One guy? Come on, more. Nobody used bugs.wireshark.org for researching? Oh my goodness. That's room for improvement for the next 60 minutes, yeah? Okay. So on Wireshark, yeah, when you fired up Wireshark, what is it to set up preferences? Or I don't know the menu items clearly, yeah, but the preferences of BGP, not too much, huh? It's a TCP session, port 179 as destination port, yeah, for the BGP server. And then the length of the AS number, you can select the 3 options, yeah, auto detection, 2 or 4 octets, yeah. This is important when you're capturing in an environment when you have 2 octets for ASN and also 4 octets, yeah. Another thing I use very often in Wireshark is a display filter expression, yeah. So Gerald mentioned in the morning in the keynote, yeah, how many fields Wireshark have right now, yeah. That was 185K fields, yeah. And I know some of these fields, yeah, but not so much, yeah. And for BGP, a lot of fields there. And the most important thing is when you go in Wireshark of the dissection, go here to copy and field name, yeah. I forgot sometimes the shortcut, yeah, but it's very useful when you use Wireshark in the GUI version, yeah, or in the graphical version, using some shortcuts to be faster troubleshooter, yeah, or to find the needle in the haystack very fast, yeah. And this field name, yeah, we will use it. I will make a demo right now or later on. It's very useful, yeah. Some RFC for your reading, yeah, on the airport or on whatever you call it, yeah. And the thing is, some private AS numbers, yeah, for 2 byte or for 4 byte. They have a special meeting, yeah. Everyone can use it like RFC 1918, yeah. Who knows RFC 1980, by the way? Oh, some guys? Okay, more hands right now, yeah. That is a private IPv4 address space, yeah, for IPv4 unicast, yeah. And so also for BGP, you have some private AS numbers, yeah, autonomous system numbers. So this display filter expression, yeah, as I mentioned before, I learned from the display filter expression a lot. Every time when I go to Wireshark, I go to display filter expression. I'm not reading the source code, yeah, I have also the source code of the dissector of BGP, but with the display filter expression, yeah, I go into, jump in and see, okay, something happens, yeah, BGP notify major error, message header, open message error, update message error. And then I go, oh, what can happen, yeah? Which options are available? And then I extend my protocol knowledge with that, yeah? And I can advise you, use it also, yeah? Display filter expression is a good way to learn or to extend your protocol knowledge, yeah? For BGP, this is one example, yeah? This is for the minor errors, yeah? See PRT configured or clear IPGP, IPPGP mark, yeah? That is the worst thing you can ever do in a service provider environment, yeah? So let's go on. So what's happened, yeah? Notification tells you what's going wrong sometimes on BGP, yeah? So there are some examples, and this here, yeah, are the strings you should remember for the display filter expression, yeah? In Wireshark, you can see it on the left corner, yeah? Some text sometimes, yeah? The most horrible thing you see on the left corner is when this item bracket text. I'll show you later on, yeah? And then with the notification, I was, okay, I have 2 trace files, and checked what's going on here with the major error and the minor error. And I found out on the left side, on the right side, what are the difference, yeah? As Hansang told you in the morning, yeah? Make a baselining of your capturing. It's so important, and you compare 2 trace files, yeah? What are the difference? Do you know, by the way, how you compare 2 frames in Wireshark? I got one call from a customer, or from a colleague and customer also. He asked me, can you tell me very quick how I can compare 2 frames? There is one option to impress your manager, yeah, in Wireshark. On the hex code, switch it to binary, yeah, ones and zeros, and read, okay, 001, 001. Ah, there's a difference, yeah. There's one thing, yeah. But you can use it Wireshark also with T-Shark, with the CLI version, and capture or read the capture file and export the content of the frame as JSON, and then make a diff on both, and then you see what's the difference, yeah? So we're here, a notification. There's a capture file I shared with you, available on the internet also, yeah? And have a look on this trace file, yeah? What is the notification tells you? The thing is, you have the major error code and the minor error code, yeah? And in this case, they tell you that the extension is not supported, yeah? One guy, the one BGP speaker, advertised something, and the other guy cannot understand it, yeah? And tells them back, by the way, multi-protocol extension capability I'm not supporting, yeah? It's like in TCP, yeah? Make a reset, yeah? Or a push. Bring something back, yeah? Another thing, I was curious when I read something about BGP. BGP support authentication, yeah? And I was looking, okay, IP, TCP, BGP. Where is in BGP the authentication, yeah? In BGP protocol, for the decoding, there is no authentication. The authentication is done in TCP. It's done on layer 4 and not on the BGP, yeah? And that is sometimes when you read some firewall guides, why say authentication through a firewall with a BGP session are not supported when they randomize the TCP ports and other things, yeah? There's one option, and with display filter expression again, see it, all the predefined values. Please read the predefined values very carefully and ask every time what this value means, what the other value means, yeah? And this is the way I extend my knowledge very quick, and I found it out. All these guys, the code developers, yeah, make a good job. They describe something, yeah? Predefined values helps you, yeah? What's happened when you mix something with the authentication, yeah? On the one side, you have MD5, because it's not secure anymore, yeah? Because you have a lot of collisions right now, but it's a standard way. And on the other side, you have no authentication, yeah? Both cannot talk to each other, eh? You see on your log files, something happens going wrong, yeah? But on the capture side, you have also a good view with Wireshark to decode it, yeah? There was another thing, yeah? I was also aware there's for TCP an authentication option, yeah? And also here, this value. So I refer to other standards or text files from IANA or RFCs or whatever, and check, is it correct what these guys who built up the dissector written down? And every time, or mostly, everything is okay, yeah? But when something going wrong, you know what you do? Open a case on the bug tracker, yeah, with Wireshark. Okay, BGP, that is only for information, yeah? Hijacking every time, yeah? But this is BGP on the internet. What's happened with BGP on your intranet, yeah? In your data center. Because BGP, one usage is, the mainly usage is the internet, yeah? But what's happened on your data center, on your local area network, yeah? Or on your customer network, whatever, yeah? With this AS numbers, 2 and 4 bytes, yeah? They use it for the interaction, yeah? One guy is only capable of 2 bytes, and the other guy is capable of 2 and 4 bytes, yeah? And then what's happened when this guy for 4 bytes will speak to the guy who have only 2 bytes capability, yeah? I was surprised, yeah? They have a special AS number. And in Wireshark, you will find it AS_trans, yeah? Because the AS number is carried in different messages of BGP. And you must be aware of that, yeah? So display filter expression again, yeah? So don't dream by night of display filter expression, yeah? Because I'm dreaming a lot of display filter expression. So protecting you, yeah, that you're not dreaming, yeah, tonight. And then you see it, there is also a capability type with the value of 65. And the other thing I also learned from this, this is unsigned integer with 1 byte. So how is the value and on the protocol header or whatever defined, yeah? It's 1 byte, 2 byte, 4 byte, whatever, yeah? And then I scrolled up and down, yeah? What are the other things meaning, yeah? BGP extended message or graceful restart compatibility, yeah? Or support for dynamic capability, yeah? Another thing I found out in Wireshark, use the Control-C, because I'm using a Windows system, use the Control-C, Control-V, yeah? For copy and paste. And when you go over with your mouse on this field, make a Control-C, then it's copied in your paste thing, yeah? For pasting to another text document, for example, yeah? And display filter expression, as I told you, is one way, yeah? It's my way sometimes on the highway, yeah? As Hansang said, yeah? Another highway, yeah? And RFC reading also, yeah? By the way, RFC, Maha? RFC 9025, you know it? Good. See, this guy read also RFC, by the way, yeah? Who knows RFC 9025? Wait. Yeah. Because the guys in the background can hear it.
Yeah, Ross Cullum wrote it in 1995, I believe.
1925?
1995, he wrote this RFC 1925. It's 12 networking truth.
Okay.
It's called it.
We have read this RFC 9025? Have a research right now. We have all wireless right now, yeah? RFC 1925, yeah? And Maha told you, yeah? It has to work, yeah? So, going back to BGP, this is an open message in BGP, and you see the AS number and the BGP identifier. Here's also name resolution on here. There's a captcha from, I think it was Australia, yeah? .AU. And you see the IPv4 address and the BGP identifier, yeah? It's a 4 byte. But BGP is also capable of IPv6. But the BGP identifier, it's 4 byte, and in the notation of an IPv4 address, yeah? But it's only a 4 byte value, yeah? They confused also sometimes some guys who are reading some protocols, yeah? It's only a value, yeah? Not an IPv4 address, yeah? Also like in the router ID in OSPF, for example, yeah? And then you have optional parameters, yeah? And this is the advantage of BGP to survive more than 20 years, yeah? Type, length, value. Every protocol that have type, length, value will survive when they have enough space for the definition of the type. It's important how big are the type. Is it 1 byte, 2 byte, 4 byte, or 8 byte, yeah? The Four-Octet, also using in the attribute type code for the path attribute. And you see it here when the 4-byte AS number was introduced. The dissector has been rewritten or extend to 4-byte. That was a big challenge. And you see it here in the display filter expression with the number 4 here. AS4 pass, underscore pass. And although this fields here, so what I learned from Wireshark, bug. I can search on the bug database, and there was a bug hidden here. And then I opened this bug, and when some useful guys doing that, opening a bug, all these core developers ask, can you provide a sample trace file? That is the first question you got from the core developers. And when you open a bug, please provide a sample trace file. Because these core developers, they have different areas. They are not a PGP expert like me. I'm also not a PGP expert. There are more PGP experts around, maybe sometimes here also in the audience. But when you open a bug, please provide a sample trace file. Because the developers, they are thinking in different areas, from C to C++ to C#, and whatever right now, Which language, There's another trace file in the supplemental, You can see it, that the AS number here is 4-byte, Have also sometimes a look on the hex trace code, And you can read it here. Okay, MAC address, okay, what's going on, and so on, And you see here, FFF. This is the PGP marker. There are 16 bytes, these FFF, And this marker, by the way, was used here for PGP interoperability between version 3 and version 4, To check, is that version 3 speaking or version 4 speaking, I got that information from RFC, Because I was reading RFC again and again, and this was the result of that, Okay, this is the hard way, On the highway. Reading C code, Who, by the way, reading the dissector C code? Nobody? Oh my gosh. You should do it. Because on the dissector, wait a moment, I will show you. Who is it? And this is the dissector of packet-pgp.c. Everyone have access to this source code, And you see a lot of RFC, also mentioned inside, And you see, by the way, these are the types, that are mentioned on the napkin also, several years ago, On the napkins, they made an error, They put the number of the type different, But they corrected in the break also, They found it out, corrected on the napkin, everything okay, And with this dissector, when you go to the end, 10K lines of code, only for one protocol, it's BGP, So Gerald mentioned in the morning, how many lines of code Wireshark have right now, are there. Who remember the figure?
2.7 million to 3 million.
Okay. In comparison to PGP, PGP is a very small protocol, And how many protocols Wireshark can dissect right now? You have also the figures? 1,400. I was thinking 2.5K or something like that, huh?
No, it was over 2,000 this morning.
Over 2,000?
This morning it was over 2,000.
Okay. This is 1, yeah? So 10K to 1, you see the ratio, yeah? And this dissector, by the way, is not so complex, yeah? So let's jump over and go back. This is one way, yeah? Another thing is some text file from IANA, yeah? A lot of useful information. These are the standards, yeah? Because BGP is not spoken by only one vendor. It's a multi-vendor protocol, yeah? Vendor A, B, C, D, yeah? Anything but blah, 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 yeah? And you see a lot of options here, and it costs me a lot of time to read everything, yeah? All these RFC, for example, yeah? Too much. On the way here to the SharkFest, yeah? I was reading on the plane some RFC, yeah? And then Germany plays. It was Osaka, yeah? So, RFC gun, yeah, sorry. Communities, it's also a big key element in BGP, yeah? At the end of the presentation, I will show you a very useful usage of BGP communities, yeah? Say, play something over the internet with BGP communities, yeah? The battleship. It's a very good thing, yeah? And with communities, there's different things, yeah? You have standard communities, you have extended communities, and large communities, yeah? And they invited different things for different purpose, yeah? And with community-based right now, something using for filtering, yeah? Or policy with BGP routing, yeah? So the large BGP communities are defined in another RFC, and you see it here, local data part 1 and 2, yeah? And also here, this number here, yeah? 2 of the power of 32, yeah? For me, it's every time I can calculate 2 power of 16, yeah? But the power, 2 power of 32, it's for me always hard to remember this figure here, yeah? But I make a hint for me, yeah? 294, 295, and it's hard always this number in the middle, yeah? But 2 power of things, yeah? So that means 32 bits, 4 bytes, yeah? There's another thing, yeah? With communities, you can do some load balancing, yeah? Equal cost multipassing and load balancing into BGP or other routing protocols. It's right now the state of the art, yeah? Because when you have a network, you make it a redundant network topology normally, yeah? And not a single one. And equal cost multipass load balancing is a very good thing, yeah? I had a talk, I think it was 2 years ago, the same area here in the Computer History Museum about layer 2 stuff, yeah? With link aggregation and something like that, yeah? It's hard to capture. And you need a lot of capture equipment. For example, on this Beckett Bay, yeah? You see one capture appliance. There's only one, yeah? But in a link aggregation, yeah? You need more. And with equal cost multipassing load balancing, yeah? To troubleshoot it and to signal it via BGP, yeah? With BGP communities. Oh my God, so many words, yeah? In one sentence, yeah? Hard to follow, I think, yeah? After so many sessions, yeah? But this here is one thing, yeah? One usage of BGP. And there are so many usages of BGP right now. I was a little bit surprised when I make the research of this talk, yeah? How many usages are for BGP right now in the area? Everyone uses it a different topic, yeah? And it's hard to get an overview of that, yeah? I found out another community. And I was thinking, okay, this value, something come into my mind. 3 times 6. Who know it? Some guys? Can you make it an announcement for all?
It's the evil, eh?
Yeah, evil.
666.
666 evil, yeah. Do you know, by the way, where is it also used?
It's for BGP black hole. Yeah?
It's BGP black holing, this guy. But I ask, which protocol, by the way, use it also 3 times 6? You guys, when you make a trace route on a Windows system, and a trace route, I see some Macs here right now, they ask you for a UDP port, or trace route on a Unix system and on a Mac system, it's based also on Unix kernel, yeah? They use it for trace route and UDP echo instead of Windows, yeah? It's an ICMP. You know the difference sometimes? And they use it all the UDP port 2 power of 32 divided by 2 plus 3 times 6, yeah? That is a starting. So a good time from my side, when you go out for drinking some beers, there's a TCP IP drinking game. You know that? Use your search engine, yeah? TCP IP drinking game. It's not, it's real. And that were also guys like you and me, yeah? They drink something and, okay, let's define what is the Ether type of this, what is the RFC of IP, yeah? What is the RFC of ICMP, what is the RFC of TCP? Laura, in this class or in the workshop, yeah, always mention RFC of TCP, yeah? 793. Yeah. Okay, coming back to BGP. So BGP also interact with IGP, yeah, with OSPF version 2 and OSPF version 3. And this is a pitfall of OSPF, by the way, yeah. OSPF version 2 have no type length value. For IPv6, you need OSPF version 3. In ISIS, for example, you have type length value. This is a big advantage of ISIS, but ISIS is not based on IP for you guys. It's based on OSI, yeah? And that is why you hate ISIS, but the service provider, yeah, using normally ISIS for IGP and not OSPF, yeah? Because they're using a service provider network, IPv4 and IPv6, yeah? There's also a good project right now. Several years ago, we had a guy here, I think it was Jeff Carroll. He was talking about OpenFlow and SDN. And SDN right now is a buzzword, yeah? Everyone uses it. Oh, we're using SDN, but nobody uses it, yeah? They use it always, the vendor solution, yeah? They called it ACI from Cisco or from Juniper Virtual Fabric or from Brocade or whatever, yeah? Or from VMware, yeah? And this BGP Link-State extension, yeah, for segment routing, yeah. By the way, I met this guy one time at, I think it was a vendor show. I met this guy who wrote this RFC. And this guy also, yeah, by the way, was a core developer for Wireshark, yeah. He wrote the dissector, not for BGP, for ISIS. It's an Austrian guy, yeah, by the way. It's Hannes. And the segment routing is also an extension to BGP, yeah? Type length value, yeah? And this a very keyword here in BGP, network layer reachability information, yeah? Also other words, very important, yeah? Address family, sub-address family, yeah? So I looked in my RFC or in my standards, yeah, which value are for which protocol, yeah, that are used with BGP. So come on. Yeah, you can find that also, by the way, in the dissector, yeah? So let's look together. What was the number? these are the best things of a dissector reading, yeah? The comments. Who participated from you guys, Laura's class? Okay, a few. You have read the dissector of TCP in Laura's class? No?
No.
Please do it, yeah? RFC 793, yeah? And packet-TCP.c. There is so many information in the dissector of Wireshark that you learn TCP basics, yeah? Don't ask for advanced, for example. Please read first the basics and then advanced, yeah? And not the vice versa. I made the mistake sometimes also, yeah? I ask for advanced and don't understand the basics, yeah? Like in PGP. I know how to configure everything, yeah? In a vendor environment, yeah? From vendor A, B, C or something like that, yeah? Or J or whatever, yeah? But how it looks like on the wire, that is more important for you guys, yeah? How they talk to each other, yeah? As Janice told yesterday, yeah? Talk to each other, yeah? Just communicate. And this is also for PGP, yeah? How they can communicate and exchange something, yeah? And in the dissector, you find a lot of comments also, yeah? What I made, okay, comments in C. I started with a slash and a star, yeah? And ended with a star and a slash, yeah? And I checked every time the dissector make a crap or whatever, yeah? Your search engine is. And then you see, okay, so it discuss something here, yeah? In the dissector, yeah? Or it's written down, yeah? Not discussed, yeah? How it looks like for the dissecting with Wireshark. So you have multi-protocol extension capability, BGP-LS for the address family, and for the sub-address family, some values, yeah? So link-state protocols like OSPF or ISIS, yeah? OSPF version 2 and 3 are coming into PGP, yeah? It's not redistribution, no, it's part of PGP with the BGP Link-State network layer reachability information. And you see here, oh, it's OSPF, by the way, yeah? It had the value of 3. You can look when you know the trace, yeah? What is ISIS, for example? Which value have ISIS, yeah? And you see, okay, this is the AS number, the PGP identifier, the area, yeah? Because in OSPF you have the area concept, yeah? Backbone area and other areas, yeah? Not so stubby, totally stubby and whatever, yeah? But not here of the talk, yeah? And then you saw the router ID, yeah? As I mentioned, for PGP, you have also a route ID for OSPF, yeah? Also 4-byte value, yeah? So 10, 0, 0, and D means not 10. What's T0 in hex? Because this is a good joke, yeah? I traveled in the morning with another guy to here, yeah? And I said, can you express my age in hex? Because I'm becoming younger, yeah? Use that also, yeah? Okay, what's distributed with the BGP link signaling path attribute or attributes, yeah? The node attributes and type length value, yeah? This is the way a protocol survives, yeah, for a long time. Type length value. Always look for other protocols also, yeah, for LLTP, yeah, for example, yeah, in comparison to vendor discovery layer 2 protocols, for example, yeah. Type length value is the way to go. That is the way. Okay, link signaling, yeah, or link state. Although in the back database, yeah, there's a lot of information you can find with Wireshark, yeah. And hopefully on this back ID or this back ID, yeah, you have a trace file and you can study something, yeah. Download the trace file, yeah, when you're sitting somewhere and look at the frames and bits and bytes, yeah, how it looks like. To find a good resource, bugs.wireshark.org is so valuable, yeah? And I encourage you to use it, yeah? And the top notch is to submit a bug, yeah? To improve the quality of Wireshark, yeah? There's other things in the dissector, yeah? With the IPv4 prefixes, yeah? With additionally bars, there was also a bug, yeah? And not conform, yeah? And then one of the developers, yeah? Write it down something, yeah? Code inspired from decode prefix before function, yeah? The open messages, blah, blah, blah. They are sometimes also not sure, yeah? What's going on with, because they are not the protocol gurus, yeah? They are C experts or C# or C++ experts, yeah? But they are not protocol experts, yeah? The protocol knowledge coming from guys who opened a bug and submitted a sample trace file, yeah? This one here, it's very small here on the slide, yeah? But a lot of confusion I found out on different vendor implementation, yeah? There's one thing, yeah? I called it like in the old ways, yeah? When we have shared Ethernet, yeah? Half duplex, yeah? And then full duplex come into role, yeah? Duplex mismatch, yeah? That is for me BGP mismatch, yeah? Send and receive, you can send it, or you can set the value to receive, to send, or to receive and send, yeah? And also here for the sub-address family identifier. There's also a capture file, this time not from bugs via shark.org, from other location, yeah? You found a lot of capture files, yeah? But you should know where you're searching for, yeah? The needle in the haystack, yeah? On the highway, yeah? Metal to the battle, yeah? There's another thing, BGP and EVPN, Ethernet Virtual Private Network, yeah? This is the up-to-date right now in data centers, yeah? Or data center interconnects. You route or you announce prefixes via BGP of layer 2 stuff. That was for me crazy when I read that the first time several years ago. I have an IP protocol, and on top the routing protocol, and I announced layer 2 prefixes. What the hell? With an upper layer protocol, you announced lower level protocols? And I was thinking, what the fuck is going on with ARP resolution here? What is with neighbor discovery and something like that? And this I found out right now, and I spoke to several guys here working for service providers and vendors. These are the challenges they have right now, yeah? Who have heard the term, boom, broadcast, unicast, and multicast? Oh, guys, you're working in a data center? Okay, this guy know it, yeah? This are the challenges, yeah? Broadcast need to be flat. Unknown unicast, also flatting, yeah? This is a unknown unicast. This is my favorite, yeah? When going to customer and the whole network is going down, yeah, with unknown unicast, yeah? Because of MAC timer and ARP timer and whatever, yeah? That is very good. And multicast, yeah? So when you're talking about address families, yeah? I always ask when someone told me an IPv4, and I come back with the question, you mean unicast or multicast? And the same with IPv6, unicast or multicast, yeah? So we have 4 address families for 2 protocols, yeah? And by the way, I was in Singapore, yeah, at SharkFest also, and there was one guy, yeah, who provided me a trace file with IPv3, yeah? Yeah, Asian guys have IPv3, yeah? Coming back to Ethernet VPN, service provider, and MAC addresses, yeah? And the learning of that, it's very crazy, and you will see it in a trace file, yeah? Also some RFC. I printed out this RFC, yeah? I read it not only once. I read it, I think, 6 times, this RFC, and I'm not clear right now, yeah? More confused than clear. because so much things inside of the RFC, and the thing is, in the RFC there is one thing, yeah? Theory and practically. Having a capture on a wire, yeah? In a data center. By the way, can you capture in your data center on every link? No. See it? That is a challenge that every guy has in a data center right now in service provider environment, yeah? They have it one link or multiple links, yeah? But in a data center, oh my God, you have spine leaf design, yeah? And many links and everything right now virtualized and not physically. It's not like using a depth from this vendor here, putting in, and then you have your capture results, yeah? It's more. Like this is a very short drawing, yeah? Very religious way, I would say, yeah? This overlay and underlay, yeah? And then you have BGP AS numbers, yeah? So it's external BGP for the underlay, for the overlay, whatever, yeah? And so different kind, different discussion, yeah? And there I found out there was another guy, I think it was working for Facebook. He was, I think it's a Russian guy. He wrote also some BGP drafts for making scalable data centers, yeah? Because Facebook, for example, have a big data center, yeah? All other cloud providers right now, yeah? Amazon or Azure or whatever, yeah? They have big issues with BGP routing, BGP to the host, yeah? I was working at a service provider customer in Germany. They're using IPv6 and routed BGP directly at the host, yeah? /32 for IPv4, yeah? /128 for IPv6, yeah? Scalable. Scalability is one thing, yeah? It's very important, yeah? And by the way, we have some words here, yeah? VTAP, VXLAN tunnel endpoint, yeah? VXLAN tunnel endpoint. This guy from the data center said, yes, you're talking the right words, yeah? You know your acronyms, yeah? That's correct. This is more here, yeah? Multihoming. When I was reading that, yeah, I was thinking, oh my gosh, 2 years ago, I was in the same place here, it was the same room, the same location. I was talking about link aggregation, yeah? And this link aggregation right now is signaled by BGP. 2 years ago, I was not aware because I was not digging into BGP so much as I am right now, yeah? But you have your spine and leaf design, yeah, with top of the rack switches. And then multi-homed the server or host or whatever you called it, and Ethernet segment there, and ID and VNI and whatever, yeah? All these buzzwords, yeah? And right now, to have a clear view of this BGP and how they work together and how you troubleshoot, that is a challenge for you guys, because you're sitting here in this session here to learn more about that, yeah? It's a big topic right now, and I found out when you spoke about SDN, yeah, that is marketing word, yeah? You guys should talk about bits and bytes. And you should know your basics, yeah? Basics are how many bytes a MAC address is, yeah? How many bytes an IPv4 address, an IPv6 address, yeah? Spanning tree, yeah? Every guy told me, oh, spanning tree is not needed anymore, yeah, in data center. We're using layer 3, yeah? No, this guy smiling always, yeah? I think he knows his stuff, yeah? Spanning tree is a very good protocol, in my opinion, yeah? It's very old, by the way. It was invited from a lady working at such time for Sun Computer, yeah? Sun Microsystems. And she also make the advantage of the follower of spanning tree, the drill, but drill right now is dead. Other concepts are working right now, yeah? And coming back here to this multi-homing, yeah? So you can see in your BGP link aggregation control protocol, that means a layer 2 control protocol is inside of BGP, yeah? For me, it's also crazy, yeah? So, going back to Wireshark and my favorite display filter expression on the highway, yeah? DFE, and you see, okay, Ethernet auto discovery route, MAC advertisement route. 15 years ago, I was in the US in, it was in Michigan, yeah? And we had the conveyor systems. And the guy who built up the conveyor system told me and asked me several times, Werner, we need layer 2 routing. And I say, it's impossible with Ethernet, yeah? Right now it's possible, yeah? With PGP. So, several capture files for your reference, when you can look different things, yeah? So coming back, because just in time, we need to be very ready for the party afterwards, yeah? Last topic, graceful restart, yeah? Control plane and data plane. And graceful restart is one feature. The PGP process died, for example, but the data plane always in operation, yeah? That means for end-to-end user, yeah, you have no disruption. And the router restart the PGP process, yeah? But they're signaling to each other, yeah? And this is one of this graceful restart, and you have a restart timer. And with timer, I got several issues. You should know the timer not only for PGP, you should know the timer for link aggregation, for spanning tree, for OSPF, whatever. And when you're a good protocol geek, yeah, you should know for every protocol the default timer, and don't change, I would say, be careful when you change, yeah? I had 2 customers, they changed the timer of spanning tree or other things, yeah? And they had several network outages, yeah? Be aware of that, yeah? You should know what is the default ARP timer, yeah? From system to system different, yeah? And for example, ask Microsoft, yeah? What is the default ARP timer on a Microsoft end host system, yeah? It depends. It's always the answer, yeah? Okay. Also, bug database, yeah? Some samples here. And I used 2 trace files to compare the difference also, yeah? On the left-hand side, we have a length of 2. On the right-hand side, we have a length of 6, yeah? And I was thinking, okay, Wireshark tells me something. What's the difference, yeah? Okay, I have restart timer, yes, no. And the restart timer value. And on this side, we have the address family and the sub-address family, yeah? So that was here for IPv6 unicast, yeah? And this flag here, yeah? Preserve for forwarding state. Wireshark tells you, yeah? Graceful restart capability, blah, 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 expert info. All things in brackets are from Wireshark, yeah? The information, the expert system, yeah? But you should become an expert too, yeah? I think so, yeah? Another thing here, flow specification, yeah, with Wireshark for your reference, yeah? So what are the next steps, yeah? When I read that, I was thinking, maybe. World changed. Everything over quick, yeah? Maybe. I hope so. We'll see. And this was, I found out, they use it a battleship game with PGP, yeah? They set it up 2 routers, they communicating each other, and they make a battleship, yeah? With the communities hit and falls, yeah? You can use it, yeah? It's very, it was very actual, yeah, right now. It's not old, yeah? Okay. Any questions so far? Hope you have fun. I had fun with you guys. When you have questions, come to me. Otherwise, please provide feedback, yeah? Because Janice punished me every time. When something was wrong, please don't write it, yeah? Tell it to Janice, yeah? Otherwise, thank you guys, yeah?